All right, part 2 of 5.4, half angle formulas. Take notes, and hopefully you are checking in for attendance. All right, 5.4, part 2. All right, so in part 1, we looked at the half angle formula for sine and for cosine, and we did one example, cosine 75 degrees. Okay, so here we're going to take a look at a different type of example here where we start looking at quadrants again. All right, so suppose if cosine A equals 3 over 5 with angle A between 270 and 360. Okay, find sine of A over 2, cosine of A over 2, and tangent of A over 2. We haven't gone over the formula for tangent A over 2, but if we know sine and we know cosine, we can use the fact that tangent is sine over cosine. Okay, so that's how we're going to do this tangent A over 2, using the fact that it equals sine over cosine. And then after we do this example, then we'll take a look at the half angle formula for tangent. Okay, and then that will be it. Okay, so all right, so A is between 270 and 360. So again, whenever they're giving you information about quadrants, definitely draw it out. Okay, so here we are. Okay, so A is somewhere in there, and we know that cosine of this angle A, cosine of angle A is adjacent over hypotenuse. And we've seen this before, but in case you don't know how we're going to get the third side there, I'll do it over here. We'll call it B. You can call it A. That's fine. Just know that you're looking for something. Okay, so 9 plus B squared, Pythagorean theorem. And it's going to be 4. Okay, so 16. So B equals 4. But again, we're in this quadrant here. So whenever you're doing these quadrants and solving for part of the right triangle, always pay attention to whether or not it's going to be a negative or a positive result. Okay, so this distance is a y distance, right? Y is positive up here, y is negative down here. So this is actually going to be -4, not +4. Okay. Okay, so then find sine of A over 2. So let's do that one first. So sine of A over 2. All right. Okay, so we have to first figure out whether or not it's going to be positive or negative, right? Okay, so let's go all the way up here. Here is the original. This here, okay, angle A is between 270 and 360, right? We're going to use this to determine if sine, cosine will be positive or negative, okay? And the way we do that is by doing this. 270 degrees, A, 360 degrees, right? That's what they tell us. And we want to know where A over 2 is going to land. So what we do here is we take this inequality and we divide everything by 2. Okay, so divide everything by 2. There's our a over 2, divide this by 2, divide this by 2. And it turns out that a over 2 will be somewhere between 135 degrees and 180 degrees. Okay, so this here tells me, oops, a over 2. This here tells me where a over 2 lands. A over 2 is somewhere between 135 and 180. So it's going to be somewhere in here. Okay, so it's somewhere in here. Okay, so that tells me a lot. It tells me that over here, sine is going to be positive. It tells me cosine should be negative, right? And then, of course, tangent will be sine over cosine, which will be negative. Okay, so that's how you can determine the sign. The sign meaning positive, negative, not sine, S-I-N-E. Okay, all right. So here, so when we do this, we already know which of the two, positive or negative. We already know it's going to be the positive one. Okay. All right, and it's going to be 1 minus cosine A all over 2. And then here, we'll go ahead and plug in for cosine A. Cosine A is 3 over 5 all over 2. Let me make my radical a little bit taller. Okay. I'm going to multiply everything by 5 to get rid of that little fraction that's within the bigger fraction. So I get this, and then I get 2 over 10, which is just square root of 1 over 5. Square root of 1 is 1. Okay. If I rationalize the denominator, I get square root 5 over 5. Okay. And it should be positive. Okay, let's do cosine. Let's do cosine of A over 2. All right, cosine A over 2. And we already determined that A over 2 is an angle between 135 and 180. So that's going to be in here. And cosine is negative. So we are going to take the negative square root. I'll draw it taller this time. All right, 1 plus cosine A all over 2. All right, so 1 plus cosine. So that's going to be 1 plus cosine A is 3 over 5. All over 2. And just like the previous problem with sine A over 2, I'm going to go ahead and cancel out this 5 by multiplying everything by 5. So I get 5 plus 3 all over 10. And I get negative, and I get 8 over 10. And I get 4 over 5. And so that's just going to be 2 over square root 5. And so I get negative 2 square root 5 over 5. Okay. Again, I am at this point. So from here to here, I split the radical. So I take the square root of 4 and I take the square root of 5. Square root of 4 is 2. Square root of 5 stays. And then at this point from here to here, I rationalize the denominator by multiplying by the square root 5 here and here. I get square root 25, which is 5. Okay. All right. And then tangent A over 2 is just sine of A over 2 over cosine A over 2. And so that's just going to be, what did we get up here? Square root 5 over 5 for sine, and then negative 2 square root 5 over 5 for cosine. Simplify that, the 5's cancel out. So I get square root 5 over negative 2 square root 5. These guys cancel, so I end up with -1/2. All right. Okay. All right. So here we used the fact that tangent is sine over cosine, but tangent of a over 2, tangent of a half angle actually has its own formula. Okay, so let's go ahead and write down tangent's formula. Tangent of a over 2. So this is kind of the end of that example there. We actually have two formulas to choose from. You can use this one here. Tangent a over 2 is equal to 1 minus cosine a over sine a, or you could use tangent a over 2 equals sine a all over 1 plus cosine. Okay, so you can use either one. You'll get the same result. So let's do an example here where we have to find the tangent of 15 degrees. Okay. So just like in the first video when we looked at cosine 75 degrees. And so we looked at, okay, well, if I take half of 75, right, then I get 30, what did I get? 37.5, I think it was. Okay, and when I doubled it, then I got 75 times 2, and I got 150, and we're like, oh, this is the one I want, right? So same thing here, because we're dealing with a lot of formulas now. We're dealing with sum and difference. We're dealing with half angles, double angles. So here again, just like the 75 you could have used the sum formula. Same thing with 15. It's just that, that's just sort of a coincidence. You might be given an angle where you can't use the sum or difference formula. You actually have to use a double angle formula or a half angle. All right, so we know we're dealing with 15 degrees. If I take half of that, right? If I take half of that, then that would be 7.5 degrees. That's not anything we memorized. It's not the reference angle of anything we memorized. If we double the 15, then we get 30. That's something we like. All right, so then tangent of 15, we're going to rewrite the 15. So 15 is the same as 30 divided by 2, right? So that's 30 divided by 2. Okay, so that's 30 divided by 2. So then go ahead and use one of these two formulas where our A is 30. Okay, I'm just going to go ahead and use this one over here. So equals sine of 30 over 1 plus cosine 30. Sine of 30 is 1/2. 1 plus cosine 30 is square root 3 over 2. I'm going to multiply everything by 2 to get rid of these little fractions that are within this bigger fraction. So multiplying everything by 2, I get 1 there because they cancel. I get 2 here because 1 times 2 is 2. And here they cancel, so I get square root 3. Okay? All right. So you'll have to check to see if this would be acceptable on WebAssign. If not, you might have to rationalize that denominator, or here, rationalize denominator. Okay, denominator. Okay, so let me show you how you do that. 1 over 2 plus square root 3. So we covered it in one of the sections. I can't remember anymore. You rationalize by multiplying by the conjugate of this. The conjugate would be 2 minus square root 3 over itself. Because remember, you can only multiply by 1 written in the form of something over itself. Okay, and then once you do that, then you'll end up with no radicals in the denominator. So here we end up with 4 minus 3, and 2 minus square root 3 over 1, which is just 2 minus square root 3. Okay. All right, so that's it. So again, I did this part in my head. If you don't know the shortcut by now, then you have to do it the long way. 2 times 2, 2 times that. Square root 3 times that, square root 3 times that. Combine like terms, simplify. You'll get 4 minus 3, which is 1. Okay? All right. So that is it. So that's the end of chapter 5. Okay. All right. If you have any questions, make sure you email me or text me. Make sure you are checking in for attendance and keeping up with your homework.